Looks like we have a few folks joining. Cool. I think in the meantime, we can just sort of do quick introductions. In case this is your first time joining one of these. My name's Aman. I'm a group product manager at Arise, focusing on LLM, so kind of leaning into our LLM product line. And I'm joined by Sally Ann. Sally Ann, do you want to give a brief intro about yourself?
Yeah. Hey everyone, my name is Sally Ann. I'm a customer success engineer here at Rise. I work with teams supporting them onboarding Rise, all different use cases from LLMs to your traditional ML use cases. So great to be here with you today, Aman.
Awesome. Yeah. And Sally Ann leans in a ton on the product side too. So it's gonna be fun for us to kind of take a bit of a technical take, but also I think we're gonna do this one a little bit, a little bit differently than some of our previous paper readings. So we will go through the technical report and through breaking down technically the model that we're going to be focusing on today, but we'll also make it a little bit you can kind of think of it as like almost like a practical, like how do I actually take, the sort of the learnings from this and actually deploy them, in my own environment or kind of play around with some of the models that we're going to be showing. So cool with that. Let me share my screen. As always, if you have any questions, feel free to drop them in the chat and the Q&A section. We'll be taking questions directly from there live as well. So happy to kind of pause at any point and take those questions. Cool. So today we're going to be focusing on SLMs or small language models versus LLMs. And we're going to be talking specifically about Phi-2. So this is a relatively new small language model, and we'll talk about the definitions and what we mean by SLM and LLM. And we'll maybe use a couple of examples to illustrate. Phi-2 was released by Microsoft in December. It's an open source model, MIT license. They posted it for folks to use for kind of fully open source. So pretty awesome to kind of see this type of research entering the public. You can kind of think of it as comparable to like a Llama 7B or a Mistral model, but we'll get into the nuances of what's actually different about this model in just a second. So yeah, so we'll be covering a little bit of an overview of SLMs versus LLMs. What are the differences between the two? What makes Phi-2 exciting? Some of the sort of the paper takeaways, a little bit around evaluations, of course, and then we'll actually do a bit of a practical example of deploying an SLM locally and what that means. Cool. Sally Ann, you want to kick us off with a little bit of a primer on SLMs and LLMs?
Yeah. So I feel like for last year and a half, we've been hearing so much about LLMs. They take up a lot of our time. In the last few months, there's been this emergence of this small language model. So I think it's important to kind of talk about the differences between these two. Both are very useful for applications, but there are some nuanced differences. So starting with the small language models, one key thing about these is that they're trainable with a lot less data. So looking at Phi-2, I believe it was like 140 trillion token or billion tokens, something like that. And then when you look at GPT-4, it's like in the trillions. So a lot less data is actually needed to train these models. They're also a lot smaller. So Phi-2 is about, I believe it's 2.7 billion parameters. So it's quite smaller than some of our bigger models. And generally speaking, there's a wide range of these small language models. You have some that are like 100 million parameters, some that can be 13 million parameters there or billion parameters. So they're just a lot smaller in size. And because of that, they can be deployed locally. So that's something that Aman is going to cover on later on. But that's a super cool aspect of these small language models. That means they could be potentially deployed on the edge, which is super cool and definitely not possible for your large language models. They're really easy to fine tune for specialized tasks. And they're best for those simple tasks with like a narrow domain. So that's a little bit about the SLMs. And then for large language models, you all might be a little bit more familiar with these, but I'll cover it anyway. So these are trained on larger data sets. They have tens of billions of parameters, very large memory and compute requirements because of their size. And because of that, they're going to require substantial infrastructure for you to deploy them. They do have a larger context window, which is helpful for some tasks. And that's something that is sometimes seen as an edge over the small language models, but it really does determine or is determined by what task you're trying to complete with these models.
Got it. So is it fair to say that, LLMs feel a bit more Like, are they kind of more general purpose and SLMs are more specific? And that's kind of like one way to think about it if I was going to pick the right model for the task.
Yeah, I think that's a good way to think about it. And I think it's also another way to think about it is when you have kind of a simple task that you just don't require the power or the compute that an LLM is going to give you. That's another way to kind of think of it. So those smaller, simpler tasks, like coding, I think is a really good kind of example
Mhm.
of that.
Yeah, got it. So like something constrained, something with the, where the bounds are well known. You're not trying
Hmm.
to go from like one domain to a different domain. Like, okay, now code in like, 18th century like German or something
Right.
like that, which maybe a large language model would be able to do, or at least be able to transfer, domains quite well. This is going to be more, kind of specific tasks, maybe even, if you fine tuned it specific on that data
Hmm.
as well.
Yeah, it's perfect for that.
Awesome. Yeah, feel free, Sally. And yeah.
Yeah. So in the Phi-2 blog, it talks about the fact that it kind of borrowed from an initial paper that they did for Phi 1 and Phi 1.5, which is textbooks is all you need. And what this really focuses on is kind of an idea that we've heard throughout machine learning history, which is garbage in, garbage out. And what their whole premise of this is that they were able to train a small coding model with a small amount of data. And they did this by using a really high quality set of data. So they called it the code textbook. That's where the title comes from. Textbook is all you need. And basically, the code textbook is comprised of three parts of data. So the first one is this filtered code language data set. The second is a synthetic textbook data set. And then the last is a synthetic exercise data set. I'll talk about these in a little bit more detail on the next slides, but the idea is they really put effort into making sure that the data that they were going to use this to train this model was super high quality. So it had just the information that they were need. They were training it for a coding bot. So, it's got to be able to learn how to code. And their whole kind of hypothesis is just that a lot of muscle models are suffering from poor quality data in the training data set. So they aim to improve that by making sure that they kind of took control over what data they were going to use for training. And they found that using a high quality data set, that these small language models can actually achieve the state of the art performance on these specialized tasks. So in this example, it was coding, but you can think that you could do this with any kind of small language model by making sure that you use the high quality data. If you want to go to the next slide, Simon, I can kind of walk through
Yeah.
what these examples look like. So there are some coding data sets that are used commonly. It's the Stack Overflow. Those are very common for these coding tasks. And what they found is by doing like a random sample and taking a look at these examples, not all of them are really like high in educational value. So these are two examples of what they mean by like high educational value. The one on the left, it would be a lot easier for an LLM or even a human to learn how to code looking at that example versus the one on the right. And so you can think about it, if it's going to be hard for a human to learn from these textbooks examples, it's definitely going to be hard for an LLM to deliver, or a small language model even, to learn from these examples. So what they did was they did a combination of kind of manually annotating some of these as well as using GPT-4 to annotate. And what they did is they filtered out those low educational value samples and only included these high educational value samples in their training data set. That's the first component of their code textbook data set. The second is the synthetic textbook. So they used an LLM here to generate these short textbooks for coding examples. So there's an example here. It's defining on how to do singular and non-singular matrices. And it just includes that little code snippet on exactly how to do this. So there were a number of examples that they did this. And I believe they used GPT-3 to generate these synthetic textbooks. So this is the second component. And so again, making sure that these are all high quality and are going to be the information that they need to fine tune or train their model for that specific
Yeah.
task.
I think it's kind of interesting, maybe to pause here as well, like
Mhm.
the call out to like synthetic data being used to train this model, but high quality synthetic data
Mhm.
with labels, with, sort of reviewing the data going in, using an LLM to do some of the labeling as well in some cases. Like
Yeah.
any thoughts or insights on like, the like I actually really like the code example is pretty interesting. I know we're gonna talk about another
Yeah.
one too, but like you're right, this is just so much more readable versus, a large language model, you would think just keep stuffing more and more data in that,
Yeah.
like the scaling laws will sort of work out. But here it's super curated and even LLM generated,
Mhm.
synthetic data. So it's kind of an interesting insight there.
Yeah, and it's super interesting too because what I appreciated was their call out to the fact that you need to ensure that these examples are diverse and they're not repetitive. And that's something that kind of goes against the laws of LLMs, right? To a
Hmm.
certain degree, they're built to be very predictable. They give a lot of the same examples over and over again, use the same kind of verbiage over and over again. And so they actually made it a point to inject some randomness into this so that not only are they having these high quality, but they are diverse, which is going to be really important for any of these or any model that you try to implement this kind of training with. So I thought that was really interesting and important because that was one of my first kind of thoughts was like, okay, are you just going to get the same textbook that's maybe the same words, just rearranged slightly different? Like, how are you going to really mimic what you would get out of like a real textbook? And also ensure that, we're not just kind of exposing this new model to just like the same knowledge that the LM that was used to create the textbook had. So I thought it was a really interesting approach, and I'm glad that they made that call out because I do think it's important to be able to kind of reproduce these results.
Yeah, totally. It feels like a lot more approachable and from a reproducibility perspective than like just keep
Hmm.
shoving data in and throwing a bunch of compute. And then do you
Yeah.
want to hit on the last sort of data that they use for coding?
Yeah, absolutely. So this is synthetic code exercises, so very similar to that last bit that we just covered, except here this is going to be given basically a doc string that the LM like needs to complete. You can think of if you have a textbook from college, high school, any of those where you're, or even if you're learning to code now, there's always exercises in the back of the book that you can work on to see if you can test your knowledge. And so they used a synthetic set of data for that as well. And so again, they use GPT 3.5 for these. And they just kind of, again, tried to make sure that they had a diverse sample so that they could really optimize this training data.
Yeah, super cool. I almost think that there's some, maybe not surprising is the parallels in learning to like human learning as well, right? So
Yeah.
you have your examples, you have your sort of like textbook, and then textbook and code and exercises. So it's kind of like literally going through like what does a student need? They need like the material, the reference material, exercises to reinforce. And I think that's like a really kind of salient point here that if you actually just structure your training data in such a way that it almost like resembles what you would want to teach someone or human, like that's kind of it kind of maps pretty well to this task as well.
Absolutely. And I always appreciate like when they even put it in that kind of human relationship because it makes it almost easier for us to understand like how these models are working and like why this is successful.
Yeah.
So pretty cool stuff.
Yeah. So filtered code database, synthetic textbooks, synthetic code exercises. This is how they get, pretty interestingly high performance on coding tasks, which we'll cover in just a sec as well.
Mhm.
Um, cool. Yeah, so why is Phi-2 exciting? So I think we'll get into sort of like the the performance of the model as well in just a moment, but the main takeaways from the authors and from the initial sort of benchmarking is that the performance is really really high. It's better than a lot of models that have more parameters, which is sort of it's kind of counterintuitive. In fact, the papers or like the blog posts the authors kind of call out, this is sort of a way of sort of like going or pushing back against like scaling laws. Like you must, the scaling laws, like you just keep throwing more data, you'll get higher performance. More parameters means better performance. This is a little bit, counterintuitive in that it's actually counter to what the conventional scaling laws that we've kind of known, or expected transformers to perform with. Um, it makes a really strong case for training with high quality data sets. On the knowledge transfer bit, Sally, do you have any kind of note on that piece? And I'll jump over to
Yeah,
the
it
post.
They actually so that model we were just talking about, that Phi 1.5 that they took or they worked on in textbooks is all you need. They actually did a knowledge transfer into Phi 2.5 or 2, which I thought was really interesting. And they did see some improved performance from 1.5 just after of 2 after doing that knowledge transfer. So I think this is going to be a key technique for these small language models is them kind of building on their previous progress. Um, And so that I think that's really just the note there is that's something that you'll see is common because it accelerates training, but then it also boosts, performance. So I think
Yeah.
it's a key component of these models.
Yeah, and then I think that the call out to like synthetic data generation as well as part of the training
Mhm.
set is not a first, but it's one of the it's a good kind of like example sort of that reinforces that that would be, wherever we're going to see more of these efficiency gains of high quality data, you'll probably want to generate or at least augment your data set with synthetic data as well.
And what's interesting here too is, with the textbooks, all you need for, Phi 1 and 1.5, that was very specific to coding. For Phi 2, they did kind of expand that. So there
Mhm.
were examples of like reasoning and general knowledge that were science, like daily activities, theory of mind. Like they expanded on that with not using as much of a narrow set of data. So I think it's kind of interesting to see that even when you expand like the breadth of knowledge that you're passing in, as long as you kind of adhere to that high quality, it does pay off.
Yeah, awesome. Um, yeah, and then I know you have the context extension note, and I'm actually gonna come back to that in just a moment with what does that mean? We mentioned that
Mhm.
there's one of the limitations of this model is the number of context of the context window. But there's some really interesting research going on there as well. So I figure we could just jump into a little bit from the authors themselves, the contributors themselves. Um, and I wanted to call out a couple interesting things. So at the top, they do mention that, Phi 2 is available in Azure AI Studio model catalog. So you can actually go and download the model directly. You just have to I mean, you can get, the Hugging Face sort of version as well. They do have it up in Hugging Face, but you can get sort of all of the raw files that you need to deploy the model straight from Azure Studio. So I thought that was kind of, it was cool that they're actually like pushing towards more of an open source initiative here. It's MIT licensed. So it's actually, you can use it for commercial use as well in that way. Is my understanding. So and yeah, so these were some of the benchmarks that, so in here they're comparing Phi 1.5, which is 1.3 billion parameters, to Phi 2, 2.7 billion. So they are, doubling the number of parameters. But you see that boost and sort of obviously like the math and coding tasks, and that's like kind of where we were hitting home on a lot of the training data. But also, if you expand that breadth of knowledge, or expand that breadth of, information that you're sort of encoding in the model, you'll see improvements in the sort of reasoning and language understanding tasks. I wanted to jump into, so this was kind of interesting to me as well. The training for Phi 2 took 14 days on 96 A100s. Obviously, that's like, that's a significant rig. That's not like a, but I do think that from a research lab perspective, that's kind of, interestingly, like, if when you think about it, it's not like this took, weeks or months to train on, hundreds and hundreds of GPUs. Like, feels very feels in some way like high quality, like, very well optimized training as well. So that was kind of impressive. 1.4 trillion tokens, the total set. um and then yeah, I think this kind of makes sense. And then I wanted to call out I think that there was a note um on the scaling law piece. Yeah, here, just saw it. So yeah, our key insights for breaking the conventional language model scaling laws with Phi 2 are twofold. So I mean, they're sort of like that is a bit of a sort of, maybe a hot take, but it is interesting to sort of see the authors sort of calling out that they're, trying to that's the intention here, is trying to break the conventional wisdom around scaling laws. Um,
And it's interesting to just add one more note to that. Like they are firm on they believe that one of the key components of that is just that like textbooks all you need. Like they give a lot of credit to that being the reason why they're able to overcome. So I think it's interesting, and I think seems like they're doubling down on that approach. So I'm excited to see what else comes out of that.
yep, yep. And then this was also, I almost missed this one, but this was also interesting. So Mistral and Mixtral we covered, a couple weeks ago. A lot of models now are sort of undergoing RLHF instruction fine tuning. It was interesting. The Phi-2 did not undergo any alignment, so you can get the base model. You can fine tune it for alignment if you want, but it doesn't come out of the box instruction fine tuned, which is interesting as well. And so all of the benchmarks you see are actually going to be based on that base model, not even an instruction fine tune model, which is kind of interesting too. So let's talk about benchmarks. So the authors make some claims here, which are pretty interesting. We evaluated Phi-2 using several Microsoft internal proprietary data sets and tasks. And they mentioned the textbooks approach in the training data, but it is interesting that they use some open source, sort of. So these are sort of the sort of common sense reasoning, language understanding. These are not math and coding. These are the sort of Microsoft internal proprietary tasks. So that's, for what it's worth, that's something to take as it is, that, these benchmarks are a little bit different than the ones that you might have seen up here with like HelloSwag, Human Eval, et cetera, as well. So yeah, interesting, but it depends on how that data set is, those data sets are curated. But it is cool to see, at least, presumably on the same tasks, you see Phi-2 sort of outperforming Mistral, you see it outperforming Llama-2, in most cases up until about 70B. So it kind of surpasses 7B and 13B. They do also make a comparison to Gemini Nano 2. I think we kind of covered this in the Gemini paper last week, but it looks like it really depends on like a lot of different things around inference and performance of like why you might want to use Gemini Nano 2, but it is interesting that they sort of call out that from the API they did kind of access it, ran it on the same benchmarks as well. Then they go the sort of authors go through a couple of examples here of like math, almost like math tasks, similar to Gemini's example as well, of like, here's a math task, like explain what's going on here, and it does reason about a simple physics problem, and from something rather ambiguous, which is pretty cool to see. Yeah, and that's sort of I mean, that's really it. They don't go, there's not a full, I mean, the textbooks are all you need. Paper is probably where you'll get a little bit more of the technical meat, but yeah, from a performance standpoint, this is what the authors posted, and then the textbooks are all you need. Part 1 and 2 are actually Phi 1.5, so there's no technical report for Phi-2 specifically. They just mentioned that they're kind of taking the same approach and then scaling it up, scaling up the number of parameters to get to Phi-2. But it would be great to dive a little bit deeper on that too, should that become public. Anything else you wanted to add on the paper note, Sally? And if not, maybe we can jump into sort of the deployment piece.
Yeah, I guess the one other thing that I made note of on my end was the fact that they mentioned that they didn't use reinforcement learning from human feedback, and one of the intentions of doing that was so we could provide more research into the like vital like safety challenges, like the toxicity report that they put in the blog, and just kind of understanding like the societal biases, which I think is really important, and I don't see a lot of research teams kind of calling that out. So I'm definitely super interested in AI ethics and how we can be like socially responsible with these models. So it's cool to see that they're calling that out, and I'll definitely be watching to see how researchers take this model and apply it in that specific context.
Yeah, so that's in the technical report. You're calling out where they mentioned that as a section.
Yeah, I think it's both here and in the blog actually for Phi-2. They mentioned it right where they bring up the fact that it's not using the reinforcement learning from human feedback.
Oh, right. Yep.
Mm-hmm.
Yeah. So less of that bias is what you're kind of getting at with that point from like humans. Yeah.
Yeah, you can see it's just basically kind of the fact that it's not restricted because they don't use that reinforcement learning. It's unrestricted, so it kind of gives researchers a really good opportunity to research into these kind of ethics kind of areas of the model and understand a little bit better about what societal biases exist without that reinforcement learning, how we can enhance like controllability, and how just we can make sure that our LLMs or SLMs are not responding toxically.
Yep. And they call out as well like the performance on Toxigen, I think in the
Hmm.
report,
Yep.
which is a well-known sort of, yeah, I think this was the call out to that on
Yep.
toxicity. So yeah, seems to perform, pretty well on it compared to even some other open source models. And that could be because like you're saying, like it's getting high quality data. It's not being influenced by the bad stuff that you see on the internet, oftentimes from large amounts of
Right.
data, and other sources that GPT-4 and others are being trained on as well. Um,
Exactly.
yeah. Cool. Looks like we have a couple questions. Maybe we can take these and then we'll jump into deployment, which is really exciting. We'll have a little demo there. So the first one is we have LMs and LLMs. What is the purpose of SLMs? So I think Sridhar will what we kind of covered in the beginning is yeah, SLMs have some major sort of benefits to use over LLMs in terms of number of parameters and efficiency of the model. They're much less computationally heavy for things like inference and fine tuning. And then if you have specific domain tasks, you can get pretty high performance on things like coding or math, depending on the model you want to use. So I highly recommend checking out the paper that sort of makes that case as well. Um, and then Johnny Lin says, as a user of these models, does it matter that the training of these SLM models takes less time? Um, I mean, I think so. I mean, what I would iterate on, Johnny, is actually like the fine tuning, and then also future iterations on Phi-2 will probably go pretty fast relative to larger language models. So you might see like very specific performance bumps in specific domains. So maybe within coding, you could say let's just train it on like front end, code or web dev code. Like maybe you'll get a really high performance, specific small language model faster than you'll get a generalized large language model from a training perspective. So I think that's pretty exciting to see. Will we see more emerging small language models because they are easier to train? So from a consumer standpoint, depending on the task that you pick, that could be, something to keep an eye out on as well. And then the cost as well for inference of these is a major benefit on which is correlated to training. Um, Thanks so much for walking through this paper. If I understand correctly, this model was trained largely on synthetic data, textbooks with math and coding problems. For those synthetically generated problems, how do they verify the correctness of these synthetic textbooks? Yeah, great point. I think the authors do talk about that. I just had it up.
Yeah, I
Um,
believe they do some evaluations with, other LLMs for this. And that's kind of they do kind of that random spot checking manually, and then they also are then relying on LLM evals to assess that as well. And there's definitely, I guess, an argument to be made of is that the proper way to ensure correctness, because it could be wrong twice, but they make great efforts to make sure that they're using only correct information.
yep. Yeah, I mean, I think like they also kept because they've kept the training set rather low, like it kind of helps them. We point out that the only non-synthetic partner training data consists of 6 billion of filtered code data set, which was the first part that we talked about. And then the rest is all synthetic. So yeah, I mean, it is an interesting point to see, how much I don't think the authors talk about too much about the evals they use specifically there, but it would be interesting to learn more about that as well. Should they release more information on the training data set itself? But this is about all we have to go off of at the moment. Cool. Would SLMs, so Ayush asked, would SLMs be more or less prone to prompt injections or adversarial attacks based on how they are trained on very specific data? I assume it would be harder to exploit it into performing malicious tasks because there are not as many threats within the training data, but I'm curious to hear your opinions. That's an interesting speculation. I'm not sure. Yes, Eliane, do you have any thoughts on this one? My initial take is I would wait and see what the exploits would be for these types of models. They might not resemble the same as like a GPT-4 type of prompt injection where you can kind of get away with, kind of tricking the model in some way. But they might look different and you might still get, some type of exploit here.
Yeah, I agree with your kind of sentiment there that it's kind of early to know for sure what that landscape is going to look like. I think that there's always kind of the opportunity to get these models to perform malicious tasks just by their nature. So I think I agree. It's hard to say exactly what it's going to look like, but I don't think I would say that it's impossible for them to be exploited.
Yeah, maybe said another way, the model is going to be less capable on general tasks in the first place.
Mhm.
So compared to an LLM. So even if you are trying to get it to do something, it may not reason as well about even, like spouting out internal parameters very well. So yeah, the internal parameters that it has or the tokens it has might be less harmful in some way, but you may also just not get a very meaningful response to a potentially, high complexity type of exploit in the first place. So you may just get, garbage out in some way in that case. Um,
Yeah, this will be an interesting kind of topic to kind of follow and see where research goes with it.
yeah, totally. All right, should we do the live part? I think we've got about 14 minutes left. I figure we
Yeah.
can. So we've covered benchmarks and yeah, we can get into deployment. Did you want to kind of share your screen on LM Studio or should I go ahead and do that?
Yeah,
Um,
you can go ahead and you're sharing already. Make it easy.
Okay, cool. Got it. I'll actually share my whole screen. So what I thought we could do is actually make this a little interactive for folks. So we have a couple of tools up that might be kind of interesting for people here that haven't seen this before. So there are two tools that you can use to actually download these models and run them on your own hardware, actually, because what we've been kind of hitting home is that these are small language models. Their technical requirements, their hardware requirements are actually much lower than something like a GPT-4. That means that you can actually deploy smaller versions of these models. Think of these as quantized versions. Um, Quantization is basically reducing the precisions of a model's calculations to make it more efficient. So let's think of it as an even more slimmed down version of a small language model to be optimized to run locally. There are two tools that you can use here. One of them is open source. So if you'd prefer to use the open source route, there's a tool called Ollama. It's really easy to get started with. You just go straight onto their website. Oh, I didn't mean to download that one again. Okay. But you can go straight to Ollama as well, and the open source component of this is like all the code is open source, so you know exactly there's no the application runs fully locally. I'm going to show that one first actually. So I have it running in VS Code right now. Yep. Awesome. Thanks, Sarah. And it's really easy to get started. So you basically, you install Ollama, you run the application, and then you can just click Ollama run, and they have a number of models already ready to go. So you can go to any of these, and you can run Mistral. If you scroll down, you'll see Phi as well, Phi-2, and you basically run this command, Ollama run Phi. And it's going to I'll actually kind of exit this to just sort of kill it for you and just sort of show what that looks like immediately. Ollama, and hopefully folks can see that. I'll try and make my code a bit bigger. But this is running in a terminal. I run this command. It's actually going to interact with the CPP, which is the Llama parameters directly, just like how you would want to package up the model in the first place. They actually download it from some source. I believe it's Hugging Face, but I might be that one. Don't fact check me on that one. They're hosting the model in some way. Looks like they reference Hugging Face here. And then basically you can start running commands on it directly. So this is actually, if I type this in, hello, can you help me find my way to Toronto? It actually gives a response. This is running locally. I don't need my internet connection. So it's actually inferencing directly with Phi-2 on my machine. So now this is a pretty general task. So I could say, something more specific. So one thing you'll notice is it's not instruction fine-tuned. It's going to keep spouting parameters. You can actually tune the amount of tokens you want it to produce, and all of those parameters are actually tunable. Amount of tokens that it should output, the weight, the temperature, etc. So the things you would expect to be able to tune with an LLM. Let's try to run another command. So maybe like write some code that computes, 2 plus 2 or something like that. Okay, well, it doesn't compute it, but it does actually print it out. And so it'd be like some Python code, like Python, code to, I don't know, any tasks come to mind, Sally, and we can see we're sort of a live demo. So we're gonna,
You know what I did on last night? I did one that was like, give me a function that prints a letter based on a user's or a letter of the alphabet based on a user's index or something like that.
oh, okay.
Something random. It was hard. It's hard to think of those simple functions on the
Yeah,
fly. Like, do you
let's
think it'd
see.
be easier?
There you go.
That's better than the one I got last night. Last night it
Okay,
just gave
okay.
me a list and it just took an index from the list, or it was just a
Yeah,
string.
so
Yeah.
yeah, so okay, so it just prints A right now, else input out of range. So right now it just works for like the letter A, but okay, so and then you can kind of
Okay.
provide that. Yeah.
I
A
guess that's
plus the
our prompt
index.
issue. It probably wasn't clear. A letter. It's
Yep.
probably constructed. Yeah.
Yeah. Yeah, interesting. The letter A, yeah. So I mean, but it's really cool to see like if you give it a well-constrained, one thing we still need to iterate on, I think ourselves is like actually use this in terms of like, as a co-pilot that runs locally and hook
Hmm.
it up. I've seen some extensions that let you actually reference, there's a number of co-pilot extensions out there now that run directly in your IDE. You can actually point them to a local version of your model and they would inference
Hmm.
all on your machine. So that's something I've been wanting to try out myself as well. Um,
Yeah.
cool. And then there's a couple of things you can do with the API as well. So because this model is running locally, you can actually once you have this running up, you can actually use Ollama's API and you can actually curl and hit, or so I think actually, sorry, this is going to work on, your local host. So you can actually set up a, local host sort of, this model actually running directly for inference. And you can use, basically code completion, basically very similar to what you would be doing with like an OpenAI type of interface. So pretty cool. The other tool I wanted to sort of show is so now this is closed source. It's a fancy, it's sort of it's a much more UI centric focused flow around a similar task of being able to iterate with local LLMs, run them locally. So this does point to Hugging Face. So if I'd search Phi-2, I'll get a bunch of different quantizations. So remember what we talked about before. If I pick certain lower precisions or lower quantizations, I'm going to get a loss of quality, but my model artifact is going to be a lot smaller, 1.17 gigs. If I want higher quality and higher precision, my model gets a little bit larger. It's going to take a little bit more CPU and GPU to run on my local machine. I'm running this on an M1 Mac right now for context if people are following along. But and then you can get different versions of that model, different fine-tunes of that, different fine-tunes of that model. It's pointing directly to Hugging Face Hub. So if you wanted to host your own model, you could also reference it from LM Studio. So it's pretty cool. I mean, I think you can get, I mean, the interface is really pretty awesome. So I have a version of Phi-2 with these sort of quantization parameters running, with my, as a file locally. I can actually chat with it directly here as well. So this is again sort of the same thing. Let's say, let's see if it gives the same response. So this is a quantized version now. It's a different version than the base version of the model that I was running in my Ollama terminal. No pre-prompt, just running directly on. Let's see if it works. There you go. So actually that gives a little bit better of a response. So it goes through multiple. Okay, let's see. Actually, let me read this a little bit more closely. Letters, A, B, C, D, E. If 0 index is less than the length of the array, print. Okay, actually, that doesn't seem. I don't. We gave it a basically a nonsensical coding task,
We
but
probably need to do some prompt engineering. It's
yeah,
probably a little bit
yeah,
of our fault, but
yeah. Let's see.
it is really interesting to see to just do that prompt. And what I really liked about the Elm Studio is those options kind of over on the right that you can get a little specific with it. There's even the option to like leverage that GPU from
Hmm.
your Mac, so it's super cool. If you are playing around with this live and you want to check out these models on Hugging Face, this publisher actually gives you kind of some description of each of the quantized versions that can kind of help you pick which might be best for your task. Kind of highlights where the trade-offs are for that quantization.
Yeah, you get a lot of like extra sort of things here around like time to first token, speed, your GPU and CPU usage, token count, etc. And yeah, the UI is definitely get the context length here, which I don't think. Yeah, okay. So you're
Yeah.
actually so this is what you hit. So this is probably one of the last points I think we'll touch on here. So this is super cool. You can add presets to the model. You can do things like pre-prompted as well. Each model has its own presets that you can use. The presets are, things like I mentioned before, the maybe I can just open one as an example. But it's basically, how I would, what is the input prefix the authors recommend using instruct and output for input and input prefix and suffix to kind of bound your prompt. You can add a pre-prompt, you're an assistant trained to do X, Y, Z, and then you can, of course, just change other parameters as well. Cool. And then I did want to touch on the context length, and yeah, and you can use GPU acceleration, which is pretty cool. And then also you can host it through LM Studio, which was a lot of fun actually. We did you can basically start up a server, run this on your machine, and there you go, you have a model running on your machine. Cool. Let me see if there was anything else, any of the tabs here. Yeah, this was like print prime. This was an example, I think, that I was trying to run with Google's Gemini. So this was kind of one of the last things I want to point out, which was there's some very emerging research and work that people are doing to actually extend the context lengths that these small language models can basically take. So I think this was long LM, I think was the work here. So you can self-extend the token limits and basically, this is, I think this is something we want to dig into a little bit more, but if you take one of these off-the-shelf small language models and you continuously extend the token limit, basically transferring the previous call to a new call and kind of continuously doing that, you can actually get for what it looks like to be some pretty interesting results. So I do want to call out that, like we do say that, context extension is something that we're going to keep an eye on as well. It makes it kind of interesting to look at in the future for these smaller language models. Okay, we have one question. When using models locally in Llama or LM Studio, do they retain conversation context for subsequent questions in the same session? Yeah, great question. They do, I believe, in my understanding is this is all one chat context. So let's actually test it out ourselves. And if not, I think that might be a parameter. It looks like I have to reload model. Okay. Let's see if this works. So I'm going to load it back in. I believe that they do, but we'll test it out as well. Okay. Oh, okay. Well, and interestingly, it does say the result of the so I mean the prompt doesn't the prompt I just provided doesn't really give a great response, but it does actually prove the point of the Python function sort of retaining in the context window. So it is one session running. I think maybe because I was messing with some of the parameters, that this requested and passed through correctly. But we do kind of underscore the point of the retained context. Cool. That was, I think, all we had. Anything else there, Sally Ann, you wanted to hit home on?
No, I think just the local deployment, as we touched on earlier, I'm really excited to see what applications come from that. It just kind of just opened up the possibility of these SLMs being deployed on the edge. So lots of cool use cases I think are to come.
Yeah, and you can expect more on the eval side from Arise, more around how to monitor these models. If you're running these deployments locally, monitoring what the outputs are, how to evaluate them. A lot more tooling coming from us as well in that space, especially from an open source tooling perspective with Phoenix. So, expect that you'll be able to have tracing, monitoring, and evals on these SLMs once you start experimenting with them. And if you have any feedback, feel free to drop us a note on Twitter or on LinkedIn. We're happy to take any feedback on how these sessions are going, what you liked, what you didn't like. and then also, what you'd like to see in future ones too. But yeah, thanks for joining. It was great having you all, and thanks for all the great questions.
Thanks, everyone. Bye.